Welcome, ladies and gentlemen, to the second of two tricky trigonometric identities videos. I think I've solved a couple of technical issues that were plaguing me on the last video or two, so hopefully this will go very smoothly. Here we have secant plus tangent divided by cotangent plus cosine theta, and let's find that that is the same as secant theta tangent theta. As illustrated in the part 1 video, and I strongly recommend you watch part 1 to kind of get some general strategies that we're not going to cover in this video, we are going to turn everything into sine or cosine. Perhaps we can see things may simplify, or in your words, cancel, and let's just try it. So secant, let's look at the numerator of our complex fraction. Secant theta is going to be 1 over cosine theta. Tangent is going to be sine theta over cosine theta. In our denominator, we got cotangent theta plus cosine theta. This is going to be cosine theta divided by sine theta. And cosine is just going to stay as cosine. Now, like we did in the previous video, I want to combine these fractions here since they have common denominators. So I have 1 plus sine theta divided by cosine theta. Now, in my denominator here of my complex fraction, I got cosine theta divided by sine theta plus cosine theta over nothing, just 1. So I have to get a common denominator by multiplying the top and bottom by sine theta. So multiplying by 1, this cosine by 1, I can now get a cosine theta plus cosine theta sine theta. Now I have a common denominator of sine theta, and here I have my problem. Now you might think to yourself, wow, this looks actually worse than before, but have faith, sometimes you have to go a little bit further just to see if you're on the right track or not. Now, I have this complex fraction of a fraction divided by a fraction, so dividing fractions, please don't cry. Skip the first fraction, and we will just by writing it down. Flip the second fraction, which we will do so by putting the sine in the numerator and the cosine theta plus cosine theta sine theta in the denominator, and multiply. Again, the rule is dividing fractions, please don't cry, skip, flip, and multiply. And there's the multiplication symbol. So, what do we do now? Doesn't look like anything simplifies or cancels in your words. Well, let me look at this denominator here. I'm noticing this denominator has cosine plus cosine sine, and this numerator here has 1 plus sine. Well, if I do some factoring, I can factor out a cosine theta and get 1 plus sine of theta. So now this is now converted into this, and you can see that now we can do some simplification like so. Now at this stage, you might be tempted to take the cosine and the cosine and multiply them together and make cosine squared, but if I just keep the first fraction unmultiplied by the second fraction, like so, now I can see this 1 over cosine is equal to secant, and the sine over cosine is equal to tangent, which gives me my answer. Which goes to show you that sometimes you can continue working on a strategy that may actually take you in the wrong direction. This problem illustrates that completely. For this example, we're going to show that secant theta minus cosine theta is equal to sine theta tangent theta. Now our first strategy here is to turn everything into sine and cosine. So here we go. And you'll see that this cosine is already a cosine, so we don't need to do any conversions. It'd probably be nice to put these two fractions together, so I'm going to multiply top and bottom by cosine theta. So the second fraction, or the second actually term, is now a fraction of cosine squared theta over cosine. So I'll show that in a step here. Now I've got cosine squared theta over cosine. Now I can combine these fractions into 1 minus cosine squared theta over cosine theta. Now, this 1 minus cosine theta is actually equivalent to sine squared theta, because we can take our first trigonometric identity, which is sine squared theta plus cosine squared theta equals 1. And we can show a quick conversion of that by taking the cosine and subtracting it from both sides. We've seen these different kinds of trigonometric identities manipulated to give us some equivalencies that will be super helpful for us as we do these problems. So since we now have the sine squared theta equal to 1 minus cosine theta, now what we have is sine squared theta divided by cosine theta. Now you're probably wondering, how am I going to get to this answer of sine theta tangent theta? Well, that would just be taking the numerator and going sine theta times sine theta, all divided by cosine theta. And we can then split the fraction into sine theta times over 1 times sine theta over cosine theta. You can see that we can do this because multiplying fractions, top times top, bottom times bottom, would work out just fine. So that gives me my answer, my desired answer of sine theta tangent theta, because sine theta over cosine theta is tangent. For this example, we've got sine theta plus cosine theta divided by cosine theta minus sine theta minus cosine theta divided by sine. How is that equal to secant theta cosecant theta? Now my first strategy is actually taken away from me. Everything is in fact written in terms of sine and cosine. So the strategy here is to basically look at each term. So I'm going to look at this term on the left here, the sine theta plus cosine theta divided by cosine theta, and realize that this is a binomial in the numerator divided by a monomial in the denominator. Well, a cool property of that is that we can actually split this up because they're both being divided by a monomial. I'm going to do the same thing over here on this side, but I will make sure that I use parentheses to indicate that these two terms will be subtracted. Because when I split this, one common mistake is that people might forget that the subtraction is working on both of these. And that will become evident in the next step or two. So now I have all of this split, and I have the problem could get very easy or more simple if we actually keep working on this. So the sine over cosine, I'm just going to keep this as sine theta over cosine theta, and then I'm going to add to this a 1. And that's key, because what's going to happen over here, what's going to be subtracted inside here, this is going to be a 1 as well. So you're going to see that these two 1s are going to simplify to 0. Now this is still a minus over here, and we're going to leave that as cosine theta divided by sine of theta. Okay, so what does this mean? This means that I'm going to distribute the negative here and here. So now what I have, and I'm going to rewrite it all the way over here, as sine theta over cosine theta plus 1 minus 1. Now here's the key. This then has to be a plus cosine theta divided by sine of theta. So what this gives me is these terms going to make 0. And now what I have is sine theta divided by cosine theta plus cosine theta divided by sine theta. Now you might get into a little despair because you might say to yourself, that's nowhere close to secant cosecant theta. Well, let's see if we can maybe combine these fractions. Maybe something good will happen there. So I'm going to multiply the top and bottom here by sine. And just for the room, I'm not going to actually put my thetas in there. And I'm going to multiply this by 1, but this will be a cosine over cosine. Again, there should be thetas here. But what this does is it's going to give me a sine squared theta, because sine times sine is sine squared, plus cosine squared theta. And then in my denominator, I have a sine theta cosine theta. Well, what's cool about sine squared theta cosine squared theta is that numerator is equal to 1. And my denominator is now sine theta cosine theta. Now, I'm going to reorder it using the commutative property, which says that multiplication can be written in any order. And what's important about that is I want to get to secant cosecant from this 1 over cosine times 1 over sine. Well, I will split the fraction using multiplication property, because multiplying fractions not a problem. Top times top, bottom times bottom. Now I have 1 over cosine, which is equal to secant, and I have 1 over sine, which is equal to cosecant theta. Pretty tricky problem, right? Well, wait until you get to the last one here. For our final example here, we have cosine squared theta minus sine squared theta divided by 1 minus tangent squared theta. That's equal to cosine squared theta. Wow, there are two tricks, or traps I should call them. There are two traps in this problem. The first trap is that the numerator is not equal to 1. You also may try to say, well, if I just multiply cosine by negative 1 over 1, wouldn't that change it negative? Well, no, that's just multiplying by 1. And you can't just make the subtraction in the middle of that binomial into a plus just because you'd like it to be there. We're not actually using the right-hand side cosine squared theta, so everything must be done on the left-hand side. That 1 minus tangent squared theta, do you think that's secant squared theta? You would be incorrect. That is not the correct trigonometric identity of secant squared theta, tangent squared theta, and 1. That can be easily shown if you take a look at your trigonometry book and see where they're coming from that. So let's look at this problem here, and let's just see what maybe we can do to start the problem. And believe me, you should see the scrap work that I have from failed attempts. So I think I should just go back to a tried and true strategy of turning everything into sine and cosine. So my numerator is already in sine and cosine, so I'll just keep it that way. Now my denominator is going to be 1 minus sine squared theta divided by cosine squared theta. Now, like I've been doing with all of my complex fractions, is I've been combining these together, and that seems to work well, and I'm going to do that by multiplying the first one by a 1, which is cosine squared theta over cosine squared theta, and that's going to give me cosine squared theta minus sine squared theta divided by cosine squared theta minus sine squared theta divided by cosine squared theta. Now again, you might say to yourself, wow, what do I do here? I've got a binomial divided by a fraction, but I want to show you that this first binomial can be written like this: cosine squared theta minus sine squared theta divided by 1 all over cosine squared theta minus sine squared theta all divided by cosine squared theta. Wow, look at that. Okay, so what do we got? We've got a complex fraction here of a fraction divided by fraction. So dividing fractions, please don't cry. So skip the first fraction. We'll just write this down: cosine squared theta minus sine squared theta divided by 1 times this fraction flipped, so cosine squared theta divided by cosine squared theta minus sine squared theta. All right, what's cool about this is that we have some cross cancellation that you call it, or I just call it simplification, because this divided by this is 1. So 1 times cosine squared theta is cosine squared theta divided by 1 is itself, and we're at the answer.